All right, welcome everyone. I have a couple of you already in Pear Deck, but if you're not in, the code is PAKBJ. We'll be using this today to do some practice questions. If you can't use Pear Deck, you can use the chat room. But I am glad to be able to chat with you all today. I miss being in class with you, but this is, I guess, what we have right now. And so I get to hear how you're doing. So let's see what you said about something bright in your life right now. Okay, someone said family. Oh, good. Oh, is the new animal is it a hamster? I'm not sure yet. But he looks so cute. Yay, it was a hamster. Oh, okay, that's wonderful. It's so nice to have a new pet that's cute and you can cuddle with, especially when we're home, but like for so much time. That's awesome. Well, I'm so glad you guys have something bright in your life. Um, for me, something bright in my life is I had my birthday yesterday and it was fun. People bought me dropped off cupcakes and ice cream, and I played house party with my friends, and it was a great time. So I am glad that even though we are stuck in the house, that we have things that are bright happening in our lives. Thank you for the birthday wishes. Yes, it was a good day. I had a lot of fun. All right. Well, I'm really glad to hear that you all liked the Ed puzzle assignment. I'll try to find some more good ones like that. Hopefully, more people will get that assignment done. I'm glad you learned a lot about how energy changes and normal life. You learned a lot about energy conversions. And so now what we're doing is we're going to be learning about how to identify energy in systems and how to identify types of energy. And we've done that a little bit, and we're now going to talk about work and loss today. So let's look at our agenda. So today we're learning how to identify energy in a system, and then we're going to learn how to identify work added to a system. You're going to learn this by watching an instructional video and answering some questions in Pear Deck. That way I can see if you understand. And then you're going to show you've learned it by completing questions found at Energy Identification 2 in positivePhysics.org. Okay. So we're in a Positive Physics Unit 13, Energy. We'll be using that website. We'll use some others as well, but I really like this one because it gives you immediate feedback to help you. So we're on the Unit 13, which is energy. So we've learned about forms of energy, which is what that video was about. And we learned that energy can be converted from kinetic types of energy, which is in blue over here, to potential types of energy, and even energies that are neither kinetic nor potential, but we can still experience them, like sound and light energy. Okay, so our main question is, how do we identify the types of energy present in a system? So last time we watched a video that we're not going to watch today, but we watched a video that told us about gravitational potential energy, kinetic energy, and elastic potential energy. And your assignment was to practice identifying those. So I want to see, after we go over these, if you remember how to do that. So there are three focus types of energy that we'll be looking at. Remember, all energy is measured in joules, but the three types are gravitational potential energy, and this is energy that exists when an object is above a reference level. So if you're standing on the ground, but then you stand on a chair, you have gravitational potential energy if the floor was your reference level. Then there's kinetic energy, and that exists when any object is in motion. And lastly, elastic potential energy exists when something is stretched or compressed. So like if you stretch out a rubber band, it has elastic potential energy. If you squeeze a spring or compress a spring, it has elastic potential energy. So springs and anything that is stretchable, you can put in elastic potential energy. Okay, What I want you all to do, if you can, and you're signed in, is to identify the energies present at each point in this system. So it says a student releases the bob of a pendulum as shown. Neglect loss. So we're not going to pay attention to loss in this problem. Just want you to tell me what energies are present at point A, what energies are present at point B, and what energies are present at point C. Try to identify those, and then I'll see if we can share any of your answers. You can also type it in the chat room. You can type A, B, and C. Okay, I see someone typed in for A. Mm-hmm. Okay. This is looking good so far. So I see that for A, everyone is saying A is potential energy, and that is correct. At point A, the bob of the pendulum has potential energy. It does not have kinetic energy because it's not moving yet. Perfect. And what about point B? This point here. Let's see what people are saying. Okay, so here at point B, I see that someone said that it has kinetic energy. Remember when you see these three lines right here? Those three lines represent that something is moving. So when something's moving, it always has kinetic energy. So it has kinetic energy, but then it would have potential energy because it's still just a little bit above the reference level. It's really close to the reference level, but it's still above it. And then C, it has no kinetic energy anymore because there are no lines here. You know those three lines that show something's moving? There's no kinetic energy, but it is above the reference level, so it has potential energy. There is no elastic energy in the system, right? Because nothing is being stretched or compressed. This is just a regular string. It's not like a rubbery string. It's just a regular string on a pendulum, kind of like those tether balls. So good. So we have gravitational potential energy and kinetic energy in this system. So we have potential. Actually, let me share this slide that someone was working on. They had all of them on for a second. Here we go. So over here, someone wrote potential, and they wrote potential and kinetic energy here. And I believe here you would have potential energy. Good, 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 good. All right, let's try another example. So in this case, we're also going to identify the energies present. So the question is that there is a cart with a compressed spring is at rest at the initial time. The student then presses a button releasing the spring. At the final time, the spring is at its natural length. Neglect loss. So we're not thinking about loss. So I want you once again to identify what type of energies are present at the initial point where the spring is compressed, and then at this final point, after the spring has been compressed, is at its natural length. What do we notice? Out of the three energies, which energies are present? Good. I see some good answers here. Yes, Carlos, I agree. Are they both present at both times, or is it which one's for the initial and which one's for the final? Good. Okay, I'm going to share some responses here. So good. So this is someone's response where they say that elastic potential energy is at the initial state and the final state only has kinetic energy. And I believe this is what someone else said. There's elastic potential energy at the initial state and the final has kinetic energy. Good job. You guys should be proud of yourself. It seems like you understood how to identify energy in a system. So now let's look at how we identify when work or loss is added to a system. So before I play this video, I'm going to tell you what work and loss are. So work is when energy is added to a system. So for example, let's say you're in a parking lot and there's a shopping cart sitting there. The shopping cart is at rest and is not moving, but you come and you push the shopping cart. So now you are an outside force that has added energy to the system because you pushed a shopping cart. And you were able to push a shopping cart because you have energy inside of you from the fact that you've been eating. And you have changed that chemical energy into kinetic energy where you're able to actually push the cart. So that's an example of work. Now, loss over here, loss occurs when energy is converted into non-useful forms like heat. So remember, we're not actually losing energy, but it's being made into a form that we can't use. So then we consider it lost energy. So that's what we mean. Oopsie, let me go back. That's what we mean when we say lost. So the energy is not actually lost. Their energy has just been converted into non-useful forms. And so loss happens with things like friction and drag. So when you are pushing something, it loses speed after a while because of the friction of the wheels with the ground. And so that causes energy to be lost, quote unquote, from the system. And then drag is another example. Drag is due to wind. So if you are pushing something against a wind current, that is called drag, and that also slows down something. And so these are the two things that we're now adding to our problems. Now we're going to add work and loss. So we're going to figure out where work and loss are happening. So this slide has the video that you will find in Positive Physics for energy identification 2. And I'm going to play this video and walk you through some things. I'm going to play it on mute, but if you would like to see it later on, this presentation will be in Google Classroom and you'll be able to watch the video, but you can also find the video on positivephysics.org. Okay, so I'm going to I have it on mute and I'm going to skip through, but here's the problem. So you have a bicyclist initially at rest, coasts downhill, then pedals uphill as shown. So this is the person. They're on a bicycle at the top of the hill. They coast down the hill, meaning they're not pedaling. Then at the bottom of the hill, you can see they're moving, and then they have to pedal to get up the hill. And then you see them moving again. So you have to say what energy is present at A, B, and C, but then you also have to say if there's any work being done or if there's any loss in between those points. So let's look at this. We already talked about work and loss. So at the beginning here, we have gravitational potential energy. The person's not moving, there's no elastic, so it's only gravitational potential energy. But then in between A and B, the person is coasting. So if a person's coasting, they're not putting in any work, but there is friction and there's drag. So because of the friction and the drag, you will say that there's some loss between A and B. There is some loss between A and B. But at B, they would have kinetic energy. They don't have any gravitational potential energy anymore because they're at the reference level, but they do have kinetic energy. Now between B and C, it says they are pedaling. And pedaling means now that this person is adding in some work. They're adding in work right here. They are taking energy that they've eaten, they're using their muscles and adding that to this system with this bicycle. So they're adding in work, but there is still friction and there's still drag from the wind. So right there, you have work and you have loss for pedaling. But then at time C here, you have gravitational potential energy and kinetic energy here because they're above the reference level and you can see that they're moving. So that's an example of how you'll do a problem like that when they're looking for you to say if there's work or if there's loss. Let's look at one more. Let me choose another one because I think they did that one. Okay, so here's a person right here where a student loads, then releases a rock from a slingshot. So it's like Bart Simpson. But they want you to neglect loss. So in this problem, the only thing they care about is work. They don't care about loss. They only care about if you've had work. So we have A, B, and C. And at point A, you just have a person here holding the slingshot. It doesn't look like it's moving. The rubber band here is not stretched, and the reference level is here at the top. So to be honest, right now, there is no energy in the system. There's no gravitational potential energy, there's no movement, and there's no elastic potential energy. So at point A, you would have none. But then between point A and B, the person moved their arm to pull back the rubber band of the slingshot. So the person had to do some work to add energy to this system. Their muscles did work to pull that elastic band. So there was some work that got added to the system. And now we have elastic potential energy because now this rubber band is stretched. Okay, so that's here, elastic potential energy. Now between points B and C, all the person does is let go. So when you just release something, you're not actually putting in work. So you have neither. So there's no work and there's no loss because they said neglect loss. So pay attention when problems say neglect loss. If they don't say neglect loss, that means you have to count it. But if they say neglect loss, that means you don't add loss into the problem at all. All right, and lastly, let's look at point C. Now we have the ball moving, so that has to be kinetic energy, but it's still at the reference level. So there is no gravitational potential energy and there's no elastic potential energy because we left the rubber band over here. So then you end with only kinetic energy. All right, let's see if we can test this out together. Let's try this question here. We'll just do one test one and I'll show you your assignment. So this one here says a ball is at rest on the ground. When a student lifts, then releases the ball. Neglect loss. So what I want you to do is identify the energies present at each point and identify work if present. So don't worry about loss. You're only going to say if there's some work being done. Say if there's work being done and identify the energies present at each point. So at point A, point B, and point C, and then between points A and B, and then B and C. What do you see? So at point A, the person hasn't touched the ball yet. This is just a ball sitting on the ground. Is there any energy? If it's just a ball sitting on the ground, Remember, the reference level is here. So you have to be above the reference level to have gravitational potential energy. But the ball is at the reference level. Okay, so good. So someone said for now, for point A, there is none, and that is correct. So for point A, there is no energy present. The ball is just sitting there. So there's no gravitational potential energy. There's no elastic potential energy because there's nothing to stretch or compress, and the ball isn't moving. So there's no kinetic energy. So for point A, it's none. Good. I wonder if I can even write. So point A is none. Ooh, I cannot write well. Look at that. That's a W instead of an N. Okay, none. All right, what about point B? What happened between point A and B? What would I have there? Remember, you have to say if there's work or loss. So in between points A and B, you say if there's work or loss done. Work or loss is only happening in between the points. So between point A and B, good. I see someone writing. You can write in the chat room. What is there anything done? This person picked up the ball. Good. Yes, I see someone writing in. So yes. So between points A and B, there is some work done. You get some work done here because the person added energy to the system by using their muscles to pick up this ball. Now the ball is here. At point B, what does the ball have? You can write in the chat room. What does the ball have at point B? Yes. What type of potential energy? Someone just wrote in. Yep. What type of potential energy if you're writing in? There's two types. We have elastic potential energy and there's gravitational potential energy. What type of potential energy does it have? Oh, I see someone wrote it. Good. So it has gravitational potential energy. You can write it PGE or GPE. So gravitational potential energy, because now the ball is above the reference point. So the reference point or reference level is here, and the ball is all the way up here. So now it has gravitational potential energy. It doesn't have any other type of energy because it's not moving and hasn't been stretched. Now between B and C, the person lets go of the ball. What does that do? That means that's nothing actually. So there's nothing that happens when you let go of something. You're not adding energy to the system and you're not taking it away. And we're not going to talk about loss because our problem told us not to. So we're going to listen to the problem. Exactly. Good. Someone said because neglect loss. And then at C, the ball is moving. So if something's moving, that means it has kinetic energy. And then it's still above the reference level. So exactly, someone wrote it in. It has GPE. Perfect. Good job. All right. So your next problem set in positive physics is going to be questions like this, where now you're adding work and loss into the problem. Let me erase all of my beautiful artwork. Okay. So we didn't get to do our second question, but right here, you're going to be doing on unit 13, energy, you're going to be doing energy identification 2 in positivephysics.org. But yep, that is all. It is 12:30. I'll release you to your 8th period class. You guys were great. Write me if you have any questions. Bye.